Hello there, it is KP the Math G, as you can see up here. Uh, I want to do a part two segment on the first derivative, increasing and decreasing functions. So I want to consider at this point h at x equals cosine x. And I want us to look at the significance of finding h prime at x, the derivative of cosine. And of course over here we have the graph of cosine. And I could have picked cosine 2x or something like that, but since my board space is kind of limited, I just decided to stick with cosine x. That will still do the job that I'm wanting to accomplish here. So cosine x, and by the way, as x is 0, this is 1, and then at pi over 2, 0, and at pi negative 1, we see that we have a horizontal tangent line here at pi, don't we? And then at 3 pi over 2, the value there is 0, and then 2 pi, the value is back up to 1. Alright, so that is the graph of h at x equals cosine x. Well, we want to find h prime at x, and I want to plot that graph right here with the cosine graph. Alright, let's do that. Anyone know what the derivative of cosine x? Now remember, it starts with a c, so we know that the answer has to be negative. Alright, well, we know that, don't we? It's negative sine of x. Well, on the side, what I like to do is just kind of take a look at y equals positive sine x, and then look at what negative sine does. Alright, just a real brief, this is just a very small picture here. Here's 0, pi over 2, pi, 3 pi over 2, and 2 pi. One thing that you can do to memorize this, if you can remember, this is 1/2 pi, this is 2/2 pi, this is 3/2 pi, and this is 4/2 pi. Of course, we know that 2 over 2 is 1, so just 1 pi, and then 4 over 2 is 2, and that's one way to memorize it if you want to do it that way. Okay. Before we move on, don't forget, by the way, to click on the subscribe button. I'd appreciate it if you would do that, and that way, you know, it kind of helps me out a little bit. But there again, I'm just here to help out. Okay, that's my basic goal here. All right, again from -1 to 1. Okay, now sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and then sine of 2 pi is back to 0. So it looks something similar to this. Okay, something like that, doesn't it? Alright, so remember now, we're not graphing sine, we're graphing negative sine. So what that means is that whatever is above here will now be dipped below here like this, and whatever is below here will come up like this. Okay, okay, something like that. Okay, bear with me. All right, so that is negative sine x, and we're going to graph that right here. Just keep in mind, anytime you see a negative, whatever you have here, you just flip it upside down. Okay. All right. Well, here we go. We got it right here. 0, negative 1 instead of 1 pi. Alright, so 3 pi over 2 is going to be up to 1 and then down to here. Okay. Alright, so roughly this will be kind of like that, wouldn't it? Okay. Now what did we graph, and what's the significance of graphing h prime of x equals, oh sorry, oh man. Alright, let me just bear with me. I have magnets in this, as you can see. You can see that. And so anyway. Alright, so let me see here. Oops. Nobody saw me try to erase on the back side of the eraser, did they? Nah, I didn't think so. Okay. Alright. Here we go now. The significance of finding h prime of x means that if we didn't have the graph of cosine and we just wanted to find out, well, where is cosine increasing and where is cosine decreasing? Well, the first derivative right here tells us exactly where it is. Now, here's what we got to remember about increasing or decreasing. As you can tell from the graph, let's just look at the graph of cosine first, and then we'll look at the graph of h prime of x, which is negative sine x. Alright, if you notice from 0 to pi, on that interval from 0 to pi, that cosine is going whoa down like that. Okay? It is decreasing. And then from pi to 2 pi, oh, well, it's going up, 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 just like that. Okay? So we see that this is decreasing. Cosine is decreasing from 0 to pi and increasing from pi to 2 pi. Okay, just by looking at the graph itself, we can see that. But here, with the derivative, we really wouldn't have to have the graph of it. We could, I mean, even if you didn't know how to graph cosine, at least you could get an idea how to graph it, because from 0 to pi, okay, we see that h prime at x is below this x-axis. Okay, it's below this x-axis, which means that everything below the x-axis is decreasing and everything above the x-axis is increasing. So we see from 0 to pi that indeed this graph is below the x-axis, which means that cosine itself, that h, is decreasing from 0 to pi. See, we see that, don't we? And also from, we can say then that h, because h prime, alright, h prime at x is less than 0, alright, then we can conclude that then we see that h at x is decreasing on the interval from 0 to pi. Okay. It's decreasing on this interval here. Okay. Well, we need to qualify this. It is less than 0 from, okay, let me rewrite that. That looks kind of, okay. Less than 0 on the interval, from, okay, now, well, we don't have to say from. We can just say from 0 to pi. Now, h, not h prime, h, or you can just say h at x, is decreasing. Alright, and in like manner, because h prime at x is greater than 0 on the interval, or just on, yeah, we can say interval from pi to 2 pi, well, what's the conclusion? H is increasing. And that's it. And that's the idea there. Okay. Alright. That is pretty much what I wanted to cover for this little bit of time here. But it is just something that you can look at. This is an easy one. Of course, I picked an easy one for you so that you can easily understand it. Okay, maybe also in learning how to write out explanations here. Now that's probably key to taking that test. Alright, so the next time we do this, there's probably going to be one of two things. Maybe we could look at the first derivative with respect to velocity and so on, but I probably most likely want to look at the second derivative, where we start talking about something like concavity. Concave up, concave down, point of inflection, and so on and so forth like that. That is called the second derivative. It only follows that if we do the first derivative, talking about increasing and decreasing functions, that we follow up with the second derivative, talking about concavity. Alright, so anyway, once again, this is KP the Math G on Black Friday, the day after Thanksgiving. And so, yeah, you're probably still enjoying some of that Thanksgiving, some of those leftovers from Thanksgiving. And anyway, whatever you are doing, I hope that you have a very good holiday week and many more great days to come. Thank you so much. And again, if you have time, if you think about it, please do tap on the subscribe button there. Thank you so much. From KP to the Math G, have a great day.